So here we have another related rates word problem. And the very first thing we always do is we carefully read the problem as many times as it takes. And then we try to make a diagram. Okay. So in this problem, we have a water tank that has the shape of an inverted circular cone. So that means it's going to look something like this. And the inverted circular cone has a base radius of 2 and a height of 5 meters. Okay, so the base radius is here, and it's 2. And the height of the cone is, from top to bottom, is 5 meters. Water is being drained from the tank at a rate of 1 cubic meter per minute. So there is water that is coming out of the tank, okay? So we know that this, the water level is decreasing. And then we are asked to find the rate, and remember rates are derivatives, and these are also derivatives, right? Find the rate that the water level is decreasing when the water is 3 meters deep. Okay, so if we look at our tank, the water's slowly decreasing. This is the radius, and this is the water level or the height. I'm just going to call the water level H. And you can see that as the tank empties, the radius that you see here and the height that you see here are constantly changing. This is fixed. This radius is fixed. It's the radius of the container, and this height is fixed. But this inside sort of cone shape of water is constantly changing. So remember that our second step is we would like to give some names to these quantities. So what are the quantities that are changing? Okay, and so for one, we know that time is changing with in minutes. Time in minutes. We also talked about there's the radius at time t. This is going to be the radius of the water at time t. I'm going to call h of t the water level. And let's see, is anything else here changing? Well, of course, we have the volume of water. Okay, and there might be some other quantities, but right now I'm going to leave it at that, and we'll add more quantities later if we need to. But we can see as the water here changes, as the water drains, that the radius and the height and the volume of the water are all changing. Okay, so next, remember, we would like to know what were the given derivatives, so the given rates. And what are the unknown rates? So the rates that we want to find. Or rate. Okay, so in this case, as I read through the problem, we are told that the water is being drained from the tank at a rate, that's a derivative, of 1 cubic meter per minute. And so the water is being drained. So that's a change in volume. Okay, so in this case, I'm going to write, and here's our volume. So dV dt is equal to negative 1 cubic meter per minute. Okay, and notice that, even though this one is positive, that's because the water is being drained at that rate. So the drained is kind of like the negative, right? Where it's becoming smaller. We're subtracting volume. And what is the unknown rate? Well, if we keep reading, it says find the rate. The water level is decreasing when the water is 3 meters deep. So the water level corresponds to the height of the water. So that's dH dt is unknown. And we want to know when the height is 3 meters. So whatever time that occurs at. Okay, so now that we have our diagram, and we have the quantities, and we can see the derivative that we're given is dv dt, and we want to find dH dt, or h prime and v prime. The idea is, in order to get the related rates, or the relationship between dv dt and dH dt, I need to come up with a relationship between h and v first. So how is volume and height, how is the volume and the height of the water, how are these related? So we must find a relationship between V and H, V of t and H of t, because remember, these quantities change with respect to time. So we know that the volume of a cone is given by 1/3 pi r squared h. Okay, so we see V here and we see H here, but there's also R. Is R constant? So can we fill R in with some sort of a constant? Well, if we go back to the previous diagram, we can see that we can't, unfortunately. R is changing as much as H is changing, right? So we kind of have this problem where we want a derivative, because we only have dv dt and dH dt, we want a relationship that only has H and V involved. But we've got R, so we need to try to get rid of R in some way. So in order to eliminate the variable R, what we can do is use similar triangles. So if you recall, the water, if I look at the cross section here, I can see the similar triangles right here. So I'm looking at this triangle, and I'm also looking at this triangle. So let me just draw those separately. Okay, and we know that the length of this side is 2, and the length of this side is 5. And for the smaller blue triangle, the length of this side is H, and the length of this side is R. So similar triangles tell us that the ratio of R from the smaller triangle to 2 from the larger triangle, so the ratio of this side to this side, should be equal to the ratio of this smaller side H to the side of the larger triangle, which is 5, so H over 5. And then this tells me that R is equal to 2/5 H. Now I can go back to the original equation, and I can say, okay, V is equal to 1/3 pi times 2/5 H squared times H. So V is equal to 1/3 pi times 4/25 H cubed, right? And just cleaning that up a little bit, we have 4/75 pi H cubed. So this is my relationship. Okay, so remember, in the next step, in step 5, we just take the derivative of both sides of the equation with respect to t. And this leaves me with V prime is equal to 4/75 pi times 3H squared times H prime. So my derivative in this case is 12/75 pi times h squared times h prime, and that's equal to v prime. And we're looking for h prime. So I can either solve for h prime at this point, or I can try to substitute the numbers that I know. I'm just going to try to substitute the numbers I know. So I have 12 over 75 times pi, and we're interested in the rate of change of the water when the water is 3 meters deep. So I'm going to replace this with a 3. And h prime is the quantity I'm searching for, and v is -1. So in this case, I have 108 pi over 75 times h prime is equal to -1, or h prime is equal to -75 over 108 pi. That's meters per minute. And the way that I would finally answer the question is I would say the water level is decreasing at a rate of 75 over 108 pi meters per minute. Okay, and notice how when I write it in this way, because I've written decreasing, the number I put here is positive. And when you enter your answers into WebAssign, you want to be careful of how it's phrased. If it says decreasing, you don't need the negative there. So this is basically what we mean by decreasing.